Hi everyone, myself Dr. E. Kumaraswamy. We are discussing digital image processing subject topics. In this video, I am going to discuss about elements or components of digital image processing system. These are the elements or components of digital image processing system: image acquisition, storage, processing, communication, display. So for any digital image processing system, first we need to capture an image. Whatever the scene you want, you are going to capture or acquire the image. That acquisition process is going to be done with the help of image acquisition component. The acquired image is going to be stored by using a storage device. Within that storage, we saved our acquired image. Once you saved that image is going to be processed for particular application. In some cases, you are going to share the saved image to someone who required that image. So for that reason, we required communication. After that, in certain situations, you required to display the image. So we are also discussing display units. So that orally, for any digital image processing system, image acquisition, image storage, image processing, image communication, display are the components. But nowadays, with the everyone having mobile phones, with their mobile camera, we are capturing different images as you wish. So these are the image acquisition components. Once you acquire the image, you are going to save the acquired image in storage. So as per the storage, earlier days there are different storage units are there, like optical disc, magnetic tapes, video tapes or magnetic discs. Later we are also used the pen drives or CD drives are used. Nowadays within every mobile phone there is a storage space which is we are calling the memory. So that memory used to save the different images whichever we capture. So after storage, if required, we are going to process, change some characteristics of the image or some background or foreground or some boundaries are going to be altered by using processing. So nowadays we are having different processing units within the mobile phone itself. We are going to edit different images. So for processing an image, we required a processor. Earlier, computer is used as a processing unit, but nowadays different processing units are available within handheld. So if you want to display the captured image, we can use a monitor. So earlier days we used TV monitors to view the images, or you can use the camera films, or you can take the printout of the image so that we get the hard copy. So these are the different display units. So all these are going to be connected one another so that we are going to be communicate from one device to other device. So that these are the components of any digital image processing system. As you know, in a dark room, we cannot see anything because of there is no light falls in the room. So that is the reason light is in the form of energy. You are going to be viewed the scene. So for this, the light energy is going to be represented as the function which is of f of x comma y. The range is from 0 to infinite, as the basic function of f of x comma y may be characterized by two components, that is, how much light is going to be illuminated on a particular object or scene, that is denoted by I of x comma y. Based upon the light illuminated on an object or scene, some of the amount of light get reflected back. So the amount of light reflection is denoted by R of x comma y. Based upon the amount of light reflection, we are going to be seen particular object or scene. So here the functions of illumination I of x comma y and reflectance R of x comma y combine to form an image of f of x comma y. So that is the reason here f of x comma y is equals to I of x comma y into R of x comma y. As you know, I is light illumination. Generally it is ranges from 0 to infinite. So here we mention 0 less than I of x comma y less than infinite, whereas R of x comma y is the reflectance. So depending upon the property of the object, that object is going to be absorb the entire light falls on the object, or it is going to be reflect some 50% or 20% or complete reflection. So depending upon light illuminated on the object and the property of the object is going to be reflect completely, or it is going to be reflect zero reflection. So that is the reason if it is completely reflection, we denote it with 1. If it is zero reflection, we are going to be reflect as 0. So R of x comma y in between 0 and 1. So if R of x comma y is 0, indicates that the object absorbs the entire light which is falls on it. So that is, there is no reflection. If R of x comma y equals 1, indicates that there is no absorption, entire light falls on that object, get reflected back. So based on application of the pixels, where each and every point in the image we represented as the pixel. So at each and every point, how much light is available, based upon that we are observe an object. So here the light intensity values are called gray level, and the location of the each point is represented by the coordinates. So here we are having x coordinate and y coordinate, where x is 0 to m minus 1 and y is 0 to n minus 1, so that the number of pixels in the image becomes m comma n. So that is m number of rows and n number of columns. At each point, how much light is available, that is represented as function of x comma y. So if the function value is at 0 comma 0 coordinates, that is denoted by f of 0 comma 0. You can observe in the right side. So at the location 0 comma 1, the light intensity function represented as f of 0 comma 1, and so on. Likewise, the last point in the image or pixel value is represented as f of m minus 1 comma n minus 1. In this way, you can represent any digital image in the form of m by n number of matrix.